All right, so oops, sorry, it's supposed to be on slide 29. Okay, so we're going to be trying to solve this equation, and we're going to try to solve it algebraically. So solve algebraically to find which 2 months are most likely to have the temperature 62 degrees. So in other words, our input here is going to be the 62F. So we're going to plug that into here. And the reason why we can use a trig function for this is think of temperature. We're assuming that temperature, like it's going to get hotter in the spring. It's going to start, or hotter in the spring. Well, then we're on the other side of the world, if that were the case. So it's going to get really hot in the summer. Then in the fall, it starts cooling down, and then it's really cold in the winter. And then it's going to start getting back up there in the spring, again, summer. So that's how come we can use a trig function here. And they want us to figure out which 2 months. So assuming we only have one period, so from here to here, they're asking which 2 months are going to have a certain temperature. And we can see that right there. So, first things first, we're going to solve for one of the months. And then once we figure out what that is, it's going to help us solve for the other month. So, we are going to plug in x1. So, our answer here, this gives us our temperature. So, this is actually our y value. That's what happens when I don't read that fast, when I read too fast. So, is it okay, guys, if I just solve this by hand and you guys know how to use the equation editor by now, right? Okay. Okay. So we're going to start off by plugging in the 62, and that's going to equal 18 sine of pi over 6x minus pi over 2 here plus 53. So we're going to subtract 53 from both sides. That's going to give us a 9 equals 18 sine everything again. And then we're going to divide by 18 on both sides. So I'm going to divide by 18, divide by 18. I get sine of this. I'm going to put the 1/2, this 9 over 18 on the right side now, just to make it a little more easier. So sine of this, go here, x minus pi over 2 is equal to 1/2. Now, here's the important thing. There's two parts in the unit circle where sine equals 1/2. Let me grab the unit circle right now before I forget. I did forget because I should have already had it open. You're right. All right, so grabbing my trig sheet. Oh, now I want ravioli. And everyone that's watching this online is super confused. All right, so we're looking for where the y value equals 1/2. And that's going to happen in two places. That's going to happen right here at 5 pi over 6. And it's also going to happen right here at pi over 6. And this is because the y value is 1/2. Positive 1/2 to be exact. So we're going to split this up into two functions. When does sine equal 1/2? So if we do the sine inverse of both sides, we're going to get pi over 6x minus pi over 2 equals, I'm going to do, the first one was, oh, I already forgot, pi over 6. And the second one was pi over 6x minus pi over 2 equals 5 pi over 6. So both of these are our answers. We just have to figure out the month now. So we're going to add pi over 2 to both sides. So we're going to do, let me use a different color because I already see problems that are going to happen from that blue button. So we're going to have pi over 6x, and even with the red, still kind of blends in, equals pi over 6 plus pi over 2. And this is going to be the same thing as pi over 6 equals 5 pi over 6 plus pi over 2. We're going to combine these, so we get pi over 6 x, and this is going to equal, our lowest common denominator is 12. So I have to multiply these two by 2 over 2. So I get 2 pi over 12 plus, I have to multiply this by 6. So this is 6 pi over 12. I didn't want to write the denominator twice, so I just put one denominator for both. And pi over 6 equals essentially the same thing, just a little bit different because now we're multiplying 5 by 2, not just pi. So this is 10 pi over 12 plus 6 pi over 12. So this becomes two different equations. I'm going to bring them over here. Pi over 6x equals 8 pi over 12. I'm not going to reduce it because I still have to get rid of this. And this is going to equal another month, which is pi over 6x equals 16 over 12. So I'm going to erase some of this other stuff because I don't need it. So I'm going to erase everything in the top over here. You guys can always rewind this later. Let me know if I'm going too fast and you guys are like writing this down or something and I erase stuff that... Oh, okay. That works. Well, let me know if I'm going too fast for you to do it as I'm teaching it. So here I'm going to do this 6 pi over, or 6 over pi to get rid of this pi over 6. And this is going to equal 6 pi times 12 over, 12. Whoops. I didn't do that. Shut up. All right. So this cancels, obviously. So we get x equals, and it's really weird. There's such a lag. I know you guys always see it as a lag, but for me, like, it's lagging on my part too. So those pi's, oh, okay. Those pi's cancel. This cancels, so that's a 1. This is a 2, so we end up getting, hang on, this is 16 over 2 for one of them. And then I'm going to do the other one, which was pi over 6 times 6 over pi x equals 8 pi over 12. I'm going to erase this blue stuff so I can have more room. So go here, then I'm going to have 6 pi here. Oh, I'm sorry, 6 over pi. So this cancels this out to make it a 2. This cancels out to be a 1. Pi's cancel out. So I end up getting x equals 8 over 2. So my months are going to be month 8, and I'm also going to get month 4. So this tells me that this one is April, and this one here is going to be August. You're awake, Nick? Okay. You missed me. You missed me telling Garrett that I was invisible. It's, he can't. You guys can't see me. See? All right. So that's the long, complicated way of solving this algebraically to get August. So number 8 means August, number 4 means April, just because of the months of the year. So I did a lot of erasing on this one, Nick. So have fun rewatching this on YouTube. All right. So solve it graphically. Wow. They made us do all that work and now they want us to solve it graphically. Or I guess, Nick, you can always just skip over to this part where they show you how to do it. Did they split it up into two? Okay, they did. So we got August and April. All right. So now we're going to solve this graphically. So we are going to plug in. Let me open up Desmos. Give me a second. Oh, I learned this trick when I was recording last time. I'm gonna take a little snippet of it. That way I don't have to keep going back and forth. I can just put this to my second monitor. Okay, so if I want to solve this graphically, I'm gonna open up Desmos. And I'm gonna type in the formula, which is y. I guess I don't have to type the y equals. I'm gonna do 18 sine of pi divided by 6 times x minus pi. And in case you guys were wondering how I'm able to type in pi, I literally just type in pi and it changes it to pi. Divided by. I, no, it's not stupid to use Desmos. It's resourceful. If anything, it's smart. You can always zoom in and out using this. Uh-huh. Let's see. Mm. So what I'm gonna do here to make it so uh, we get better ranges is I'm gonna do it from 0 to 12. I do it from 0 to 12. This makes it a little bit better. So we're looking for 62. So I'm gonna do the steps on the y-axis by 1. Easy. I'm also gonna. Okay, why isn't that working? Let me change this range a little bit because we don't need all of this empty space. So I'm gonna do 30 to, I don't know, let's say 75 degrees. Okay, cool. And I want the steps to be by 1 on the y-axis. Why aren't they showing me the steps at 1? Do it for both. Okay. Not exactly what I wanted, but it kind of helps. So if I look at this, if I look at 62 degrees, this is 2, 4, 6, 8. They're doing it by twos instead of ones. Come on, Desmos. Oh well. So we see here it's about at 4. That looks like it's about 2. And then at 8, it looks like it's about 2. Another thing I can do to solve this is I can do y equals 62, and this will give me my answers. So by me doing y equals 62, I can be like, hey, look, they cross right here. That means 4 and 8 have to be my answer. So that's how you can use Desmos to solve it a lot faster. So, yep, and they did the exact same method. They just said we set 1 equal to 62, and you're going to get your points of intersection. I don't know why they're getting a weird number. It shouldn't be that hard to do this. There are 2 points of intersection. Oh, 50 degrees. I'm sorry, guys. I didn't realize it was a different question. So I'm going to move this down to 50. 50. You know what? I'm just going to. Okay, 50. There we go. So solving this graphically, it tells us it's about a little bit in the middle of February, towards the end of February. And this is a little bit in the beginning of September. So that's how you can get those answers. And I wonder if they even said the months on this one. Oh, yeah, it did. Part of September. So most of January, part of September, it talks about it. So on here, I'm going to give myself a 5. But it took a long time algebraically. Graphing was way easier. So that's how you can solve this graphing. I think graphing is going to be a lot more useful. I didn't realize this was going to be that short. It looks like our video is going to be really short. Oh my gosh. So summary, just know that we can use all the techniques we've ever done um, for algebra to help solve this. Always watch these videos. They really do help a lot. They review a lot of stuff you want to know for the tests. And yeah, all right, cool. And that concludes Unit 4, guys.